Okay. So week 4, we're doing geometry. So first we're going to do 2D shapes, okay? And 2D shapes are just flat shapes that lie on one plane. Does anybody know what a plane is?
What?
Does anybody know what a plane is with geometry?
No.
Okay,
No.
so a
Do
plane,
you mean coordinate plane?
yeah, it's actually similar to that. So a coordinate plane is that little graph that you put points on, right?
Yeah.
A plane is one flat side. So we'll go ahead and see what that means. So you have your basic 2D shapes, right? So this one,
Yes.
yes. I'm going to
Clock.
go ahead.
Mirror. Pizza.
Okay. I'm going to go ahead and use a little pointer so that you guys can see where
What's a plane?
Yep, I'm going to get to that right now. So here, pointer. Okay, so we're going to go over the shapes and then I'll explain what a plane is so that you'll understand a bit better, okay? Okay. So right here, we have a square, a circle, oval, yep, a triangle, and a rectangle. And then we have the more advanced ones, we have a rhombus. Here, why don't we go back and look at the things of this. So a square has all equal sides, right? So all the sides are equal, all the angles are equal, and that's what makes it square. A circle is round, an oval is round, it's like a circle, but it's a bit longer on one side, right?
Okay.
And we have our triangle with 3 sides right here. And then we have a rectangle with two sides that are equal and the other 2 sides are equal, right? And all the angles are 90 degrees. Now, a cool fact is actually that squares are also a type of rectangle, right? Because the 2 opposite sides are the same. So that means that squares are also rectangles. Now we have our other shapes, a rhombus, where all 4 sides are equal, but these 2 opposite corners are the same, and these 2 opposite corners are the same. Notice how these angles are different, the ones that are right next to each other. And then we have hexagons, where you've seen them with little honeycombs, right? They have 6 sides and all the angles are equal. We have a parallelogram where 2 of these sides are equal and then these other 2 sides are equal. We have a pentagon, which has 5 sides. A trapezoid, where these 2 sides are the same, right? We have one side and another side. Then this side is longer than this one, but it still has 4 sides. Yep, do I have a question?
Could you go a little slower?
Oh yeah, that's okay. Yeah, sorry about that. And then we have our last shape. That's an octagon. And you guys have all seen this when your parents are driving and you see 8 sides, right? So those are our sides. Okay, if you can't see all the shapes, that might be because of this little thing where it shows everybody's videos. So you might just have to move that around the page. Okay, so now let's go back to what a plane is. So you see that all of these shapes are flat on the page, right? Whereas the next type of shape we'll look at, a 3D shape, is it looks like it's off of the page and it has 3 dimensions. 2 dimensions means that it's flat and it can be on a piece of paper almost.
Excuse me?
Yeah.
So you're saying like a plane means like a flat surface?
Yeah.
With a picture on it? Like,
well, the shape is not just like a picture. So let's say I have a little calculator right here. So I have my calculator, right? So now if we put it like this, you can see all of these 6 sides that this calculator has. But when I look at it flat, I can see that it's a rectangle. So this flat shape that I see is a 2D shape. Now when I look at this is a rectangular prism because it has all of these sides. So it makes it a 3D shape. But if I'm looking just at this side, it's a 2D shape because it's a rectangle. We can talk more about that when we get to 3D shapes so we can see what the differences are. Okay.
So you're saying 2D shapes are flat and 3D shapes are like,
yeah, they pop off of the like flat plane.
it's like a rectangle like this. No. Second.
Okay, yeah. Yeah. Now that, can everybody see that? This little cube right here? This right here is a 3D shape. And that's more what we'll talk about after we finish 2D shapes.
Okay.
Okay, and can everybody see what I'm doing? I know one person can't see.
I can't.
Okay, why don't I...
You get a note, right?
Give me 1 second. I'm gonna try sharing my screen again. Okay, did that fix it?
Yes. Yes.
Okay. So now we'll go to the parts of a 2D shape. So,
Side, face, corner.
yeah. Give me 1 second. I'm gonna try to figure this out, okay?
Okay.
So Ridhima, all you can see is a black screen.
I can see
All I
more
can
than
see
a
is
black
black
screen, but I
screen.
can't see the whole page.
Yeah, me too. The sides are black. The sides are black.
The sides are black. Can you guys see this whole here?
Yeah. That's...
Okay, can you guys see the whole slide now?
No,
Wait a second. Sorry.
I can't see anything. Like, not, I can see some things, but not the whole thing.
Oh, now I could see everything.
Okay.
Part of...
I can't see the whole thing.
Can you see part of it?
Yeah. Part of
Okay.
it, it's good.
I can see
I
like
could see.
faces, corners, and side, and it ends at corner where 2 sides meet. That's all it stops.
Okay, yeah, that's all the can you see this little picture here?
Yeah.
Okay, yeah, that's all there is.
Oh.
Okay. So we're gonna look at the parts of the 2D shapes, right? So we have a face, which is the inside. So we see this little arrow right here, right? And that gives you right here. And then the sides are right here, right? The lines that are around it, right here, all around. So this square, and then this corner is where 2 sides meet. So let's look at this little square, right? The square has 1 face, and then it has 4 sides, and it also has 4 corners. Okay? So now we're going to look at what the perimeter is. The perimeter of a 2D shape is how we measure the border of this shape, right? So the length that it takes to go from here all the way here and all the way around the square. So what we're going to do right now is we're going to find the perimeter by counting. So if you guys want, you can count with me, okay? So we're going to do 1, 2, or here, let me turn on my marker.
That's much better.
Okay. Okay, I'll Okay. Count out loud, okay? So I'll write on it and then you guys can all count. Okay. So we have 1,
2,
3,
3,
4,
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
20. So the perimeter of
Is
this,
20.
yeah,
Oh, now I get what the perimeter is. It's like counting around the square circle.
yeah.
Yeah.
So, yep, our answer right here is 20 units. And so when we have an answer, right, with perimeter, we're always going to put units. And units are like, say, on a ruler, right? I have this ruler right here.
I counted as tiles. Like, I counted as like a floor, and there's these square tiles.
Mhm.
I counted as like that.
Okay. Here, why don't we, unless we have questions, we're going to mute ourselves, okay?
I have a question.
And we can, yeah.
Hmm.
So if you don't count by border, I mean, like if you don't count by the border, and if you count inside the shape, like is that the same as the perimeter?
The perimeter is basically the area around. So here, I'll give you an example. So how many of you guys have fences? You can just raise your hands. You don't need to talk out loud, but if you have a fence, right, in your backyard, you raise your hand. So the perimeter would be how long that fence is, right? So you have your little square like this, right? So the length that this fence reaches is going to be your perimeter. So you would count on the outside. Does that answer your question?
No, like do you count on the inside of it? Like is that the same as 20 units?
Oh, no. We don't count the inside. That's area. So we'll get to that next.
Oh yeah, I know what units and area. I know.
Okay. So, yeah. This answer just got, okay. So, yeah. So now what units are is, say we have inches on a ruler, right? So
Yeah.
if this was in inches, right? So if each one tile that we counted here was inches, my answer would be 20 inches. Or if it was feet, it would be 20 feet. So we always have to include units when we're writing our answers, because sometimes it'll be wrong if you don't, right? Because your teacher might not know what you're saying. It could be like 20 apples or 20 computers. You have no idea what it is, right? So you always have to include units and say 20 inches. And if you don't get units, you should just write 20 units, because units is like your default term for that. So now why don't we do this next one, right? So let's all count together. So we have 1, 2, and you guys can all count with me if you want. 3,
1, 2, 3, 4, 5, 6, 7, 8,
9,
9, 10, 11, 12, 13,
14,
14,
15,
15,
16,
16,
17,
17,
18,
18, 19,
20,
20,
21,
21, 22, 23, 24. That's 24.
24. Yeah, so this perimeter is 24. And we're going to do units. See?
24.
So 24 units. Yep. Okay. Uh-oh. Let me go ahead and share that again. Okay. So now,
units the same thing?
what was that?
Are units and inches the same thing?
So inches are a type of unit. So units are basically the terms that we use for measuring.
This formula, I used it once. I know this.
So units are basically what we use to measure, right? So units, some types of units are inches, you have feet, you have meters, you have centimeters, and that's only for area and perimeter. And then you have, and there's a lot more than what I'm saying, but these are some common examples. And then for volume, which is something we'll get to next, which is for 3D shapes, you have another type of unit. And you can have like ounces, you can have millimeters. There's a lot of different types of units. So in our examples, we'll see some types of units, okay? And if you have any questions after we go over those, you can always ask them. So now we're going to find perimeter using a formula. And a formula is an equation that we use, right? So let's look at this square over here, right? So your perimeter is, you're really just going to get your perimeter by adding all your sides together, right? And so the perimeter of a rectangle or a square would be to add the length and the width first, and then multiply that by 2. So when we do that, you see that there's 1 5 here, and then there's another 5 over here. And the same thing, there's 1 5 here, and there's another 5 over here, right? So when we multiply times 2, we're just adding these 2 plus these 2. So how are we going to find the perimeter with this formula? So what we're going to do is we're going to do 2 times the length, which is 5, and then the width, which is also 5. And so does anybody know what PEMDAS is? PEMDAS is like the order of operations, meaning the order that you do something. Do addition, subtraction, multiplication, all of those operations. So PEMDAS is for parentheses, exponents, multiplication, division, addition, and subtraction. So that's the order that we do our order of operations in, right? So I'm gonna put PEMDAS up here so that we can do our math, right? So the PEMDAS. So what's the first thing that we're gonna do in this this equation? So whoever has the answer can put it in the chat. I can see. So are we gonna do this multiplication, these parentheses, or this addition first? You can also say it out loud if you want. Okay, I'll go ahead and do this one. So, okay. So the first thing we're gonna do in PEMDAS is parentheses, right? So do we have any parentheses here? Yeah, we do. So we're gonna do what's inside of the parentheses first, which is 5 plus 5. And 5 plus 5 is 10. And then what we're gonna do is this multiplication here, because that's next, right? So parentheses, we don't have exponents, and then multiplication. So we're gonna go ahead and do 2 times 10, and 2 times 10 is 20. So our answer is gonna be 20 units. And that we did it this way, and we got the same answer as when we counted, right? So now we're going to do this one with the same thing. We're going to go ahead and write our formula. So it's going to be 2 times the length times the width. And we can also do the width plus the length, right? So it doesn't really matter. So 2 times the length plus width. So first we're going to do the parentheses again, because that's the first thing we see in this equation, or expression, sorry. And so 5 plus 7 is going to be 12. So then we're going to do 2 times 12, which is 24. And so our answer is going to be 24 units. So any questions so far?
I have a question.
Mm-hmm.
My meeting was cut, so I'm like, what is PEMDAS?
Okay. So PEMDAS is the order that you do operations in. So have you heard of the order of operations? No, that's okay. So PEMDAS is really just the order that you do things in. So the P stands for parentheses, and then the E is for exponents, and exponents are like squared. You guys probably haven't seen that yet since you're only in elementary school. So you might have like 5 squared. So the squared, that would be an exponent, but you don't have to worry about that. And then multiplication and division, these two go together. So whichever one comes when you're going from left to right on the equation works. And then addition and subtraction, which are also buddies, just like multiplication and division. Whichever one you see in your equation first, you do that. So that's just the order that we do these equations in. Okay?
Okay.
So now we're going to look at area. So area is how we measure the space inside of this shape. So first we're going to count, and then we'll do the formula for that, okay? So we're going to count this together. So this is counting the squares inside the shape. The other one, perimeter, is counting the outside, right? But now we're going to count the inside. So we can all count together. So we have 1, 2, 3. Sorry about that. Okay, 3, 4, 5, 6. Very that 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So our answer is going to be 25 units squared, or 25 squares. We'll leave it on that for now. So that's going to be 25 squares. So now we can do this one, and we'll count those out. And it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, and 35. So we're going to get our answer, which is going to be 35 squares. So does everybody get the difference between area and perimeter? So perimeter is a space around a shape, right? That's not inside.
So area is basically what you're basically counting the inside than outside.
Yeah, that's right. So perimeter is what you do outside, area is what you do inside. So now we did the perimeter with the formula, right? So now let's do the area with the formula. So all we're going to do is multiply the length times the width, and that's your area. So right here we have the length is 5 and the width is 5, so we're going to do 5 times 5.
Equals 25.
Yeah, that's right. So your area is going to be 25 squares. And then the same thing here. Let's make sure we're not calling out, okay? So the area is going to be the length times width. So the length is 7, the width is 5. And again, it can be 5 times 7 or 7 times 5. Either one is okay. And you're going to get 5 times 7, which is 35 squares. Okay? So that's area of a rectangle. Now we're going to do the area of a triangle. Now the area of a triangle is something that is very hard to count because you can't exactly be exact with that, right? So you're going to get little itty bitty small bits of squares and it's not going to work out. So what we're going to do is we're going to use a formula, which is the base times height times 1/2. And because of PEMDAS, right, we do left to right. That tells us to left to right. We'll just do 1/2 times the base and the product of that times height. So we'll see what I'm talking about. And when I say base times height, the parts of a triangle, right? So you have this little 6 right here. This is your base. And this 4 is going to be your height. And now one thing is that your height will always be perpendicular to your base, meaning that it always creates this little square in the corner, and so it's 90 degrees right there. And so it's always going to be just like that with your height. So when we do that, we're going to use our formula. So area equals 1/2 times 6, which is your base, times height, which is 4. So we're going to do left to right, so we're going to do 1/2 times 6. And whenever you're multiplying anything by 1/2, that's just dividing it by 2. So 6 divided by 2 is 3. And then we have that times 4. And 3 times 4 is 12. And so notice how our answer isn't just 12 units anymore. It's 12 units squared. Because when we're talking about area, we always have to say units squared. And so if it was inches, we'd be doing 12 inches squared. Or if it was feet, we'd be doing 12 feet squared. Okay? And guys, I'm almost done. Just bear with me. I know it's a lot of talking right now, but we're going to do an interactive after this so we can all work on it. Okay? And now same thing over here. We have our base times our height. And with this triangle, you can actually say that the base is anywhere, right? Because this is a right triangle. So this can be your base and this can be your height if you want. But to keep it simple, the base is going to be what's right here so that it's easier and we don't get confused. So our base is going to be 10, our height is going to be 8. So we're going to have 1/2 times our base, 10, height 8. So 1/2 times 10 times 8. So 1/2 times 10 is going to be 10 divided by 2. That's going to be 5 times 8. So 5 times 8 equals 40. So 40 units squared. So does anybody have any questions?
Yes, I do. For the first example, and what if there was a 5 instead of the 4?
For the where did this go? Okay, so for
the first example.
Oh, if that was a 5 instead of 4, we would just multiply it just like that. So it would be 1/2 times 6, so 3, and then instead of a 4, we do 3 times 5.
Got it.
So whatever numbers you have, you're just going to do the exact same thing. So this is your basic formula, so you just plug in those numbers, okay?
I have a question.
Mm-hmm. Yeah.
So, so like when you said that we had to do like a square, like like right angle.
Squared? Oh yeah, the right angle.
Like 90. Yeah, but like, why are you saying that 4 is the only one? Because I can spot some right angles in 6 as well. And the second question is, you know that triangle thing? So when you say like anything can be height, like let's just say I say that 8 is height, so I do 8 times 1/2, but 1/2 of 8 is 4, and then it's going to be 4 times 8, so it's going to be 2 different answers.
Okay, so what you would do, if 8 was your base, then 10 would be your height. So it wouldn't be 1/2 times 8 times 8, it would be 1/2 times 8 times 10. So you're just switching around the numbers, right? So if this was...
Yeah, but the 1/2 of 8 is going to be like, like it's going to be like 1/2 times 8 equals 4, so it's going to be 4 times 8 instead of 5 times 8.
Here, why don't we go ahead and look at that, and it will make more sense, okay? So if we do say that, let's say that the 8 is the base, right? And then your 10 is height. So let's plug that in. So 1/2 times, it's a very bad one right here. Okay, so 1/2.
I have a question.
Yeah?
What if in the sixth, on the first example, instead of the 6, what if there's a 5? How would we
Okay, we'll do that next, okay? So I'll finish this and then we'll go back to that.
Okay.
So 1/2, okay, so 1/2 times the base. So if 8 was your base, we do 1/2 times 8, and then times the height. So your 10 is your height, right? So that would be times 10. So now let's do this. 1/2 times 8, so 8 divided by 2 is 4. You're right. So then we carry down this 10, so 4 times 10. And 4 times 10 is 40. So we would get the same thing. Does that make more sense? Because all you're doing is switching these, right? So originally we said that...
Of like the 8, we would just carry down the 10.
Yeah. You're going to have either or, right? One is going to be your height and one is going to be your base. So you're just going to choose.
The other thing is, like, when you said that only the 4 has, like, the right angle, I think I see right angles in 6 as well. Like, how do you know which one is a height and a base?
Well, okay, so a lot of times, the pictures that they give you, it might look like there's a right angle, right? And there could be, but we're going to assume that there isn't because we might get it wrong otherwise, right? So sometimes it looks like there is. There can be very close angles, right? Because a right angle is 90 degrees, but that picture could be 89 degrees, and we would get that wrong, right? So we're going to use what they give us, right? So most of the time, I know I didn't include this here, so it might be hard to see, but they will have your little square right there to indicate your right angle. And so wherever you see the right angle, I'm just going to automatically assume that this is going to be my base, this is going to be my height. So you don't get confused, right? Because a base is usually at the bottom when you're looking at it, and your height is how much you grow, right? When you're looking at the definition of the words. So we're just going to assume that this is your base and then this is your height. So you might think that there is a right angle right here, which I understand. Actually, there is a right angle, but a lot of times you might get triangles like, say, this, right? Or not like that. Like this. And so your base would be right here. So This would be your base. And this right here would be your height. And in that case, they would give you this little triangle or this little square, and then they would give you this measurement. Okay?
Can you explain this again? I couldn't understand it.
Okay.
I couldn't understand the
Like the base
part
type of height.
of the right square thing.
Okay. So a right angle, right? A right angle is 90 degrees. So you know in a circle, right? You have a little circle. There's 360 degrees in that circle, and a degree is just a unit of measurement. That's just how we measure a circle, right? So if you have a little pie, you have your little pie, right? And you look at this little chunk. This part, you're gonna measure that in degrees. So say this is 1/3 of your pie, then this is gonna be 120 degrees. So that it's just a unit of measurement, right? You guys don't need to worry about degrees for now, but just know that it exists, right? So now when we're doing angles, we have 3 types of angles, right? So this would be,
I understand a part. I just don't understand like why like 6 like can't have a right angle. I understand angles though.
why this one can't have a right angle?
No, the 6. Like, why can't like the base have an angle? Like why can't, even if it does, like why do we say it doesn't? Why do we only say the height has it?
Oh, okay, I see what you're saying now. Well, I'm not saying that the base doesn't, right? So the height, because the height can always be different, because look at this triangle, right?
Yeah.
There is no right angle here. There is no like obvious answer. The actual height of this would be here. You would draw a line here and connect that to the base, and this would be your height. Right, this right here, that would be your height. So because of that, we always say that the height is, your base is always going to be this flat line, right? Your height is what has a perpendicular angle to the base. That's because it's not always clear what the height is, right? So that's why we say that the height is always going to have your right angle to your base. Now, these both share that right angle, right? That's how we know that's the height. And right here, these two also have right angles. So because this triangle right here has a right angle, we can say that either one can be the base or the height, right? That's the only reason.
So like even if like the 4 doesn't have a right angle, do we just say it does?
The way, if it has a right angle, they will tell you. So all the information you need is what they tell you. So the symbol for a right angle is this little square right here, right? So that's when you know, if you see the right angle, that's when you know. Never think that there is, because this is a right angle if you look at it, right? But I only know that because I made the triangle. But this could be any degree, right? So you don't want to just say it is because it looks like one. Because on a test, say your teacher's giving you a test, right? And it says this is a right angle, but then you assume this is a right angle, and so you use the measurements that they give you here, you'll get it wrong because they didn't say it was a right angle. So only use what they say is a right angle, okay?
Okay.
Okay, now I had another question, right? If this over here on the first triangle, if the 4 was a 5, no, we would do, or the 6 was a 5, right? 1/2.
It was a 6 of a 5.
Okay, either way, so let's just say, yeah, the 6 is a 5, right? So 1/2 times 5 times 4. We just do that. And now, yeah, so we just plug in whatever number. It could be even, it could be odd, it could be anything. We just plug that in. And what we do is be 1/2 times 5, right? And so that would be multiplying fractions. So 5 over 1. Whenever I multiply a whole number times a fraction, I always put the whole number over 1. And I think you guys did this last week. So whoever was in the session last week, so you just carry over the numbers, right? So 1 times 5 is 5, and 2 times 1 is 2. So that'll be 5 halves. Now 5 halves times 4, so 4 over 1, and that will be, you multiply that, you get 20 over 2, and that equals 10, because that simplifies to 10. Okay?
Okay.
So we're
Yes.
going to move on now. And remember, if you have any questions that I don't get to in this class, you can always email us, okay? And so you can always ask any questions. So now we're going to move on to 3D shapes, right? So 3D shapes are shapes that take up space and on multiple planes, meaning that they have multiple sides. So now let's look at these types of 3D shapes, right? We have a sphere, we have a rectangular prism, we have a cone,
Cone.
a
We have
cube,
a cube. We have a
pyramid,
pyramid. We have
a
a
cylinder, and I'm not sure. Okay, so we have the cylinder, and then, yeah, so those are our 3D shapes. Now, the parts of a 3D shape are right here. So we have the face, which is the same thing as our 2D. And then we have edges, which are, instead of sides, we say edges now. And then vertex, which is instead of corners, we say vertex. So our edges are where two faces meet. So we see this one face and this other face. So this one face and this other face, and where they meet is an edge. And then where more than one face meets, or where edges meet, I should say, where these edges meet is a vertex. Now, you guys were asking what a plane is, right? A plane is basically a face in this scenario. So we have one face here. A cube has 6 faces, right? So 1, 2, 3. There's one on the bottom. There's another on this side, and there's one on the back. So any shape that has more than one face is 3-dimensional, which is 3D. And that means it has multiple planes. Now a 2D shape only has one face. And that would be 2-dimensional. So now we're gonna go do volume. So volume is like the area for 3-dimensional shapes, right? It's how we measure the space that a 3D shape takes up. And all we do to get the volume of these shapes is we multiply the length times the width times the height of these shapes. So we do the length times the width times the height, so 3 times 2 times 1. So we do the PEMDAS, which is 3 times 2, which is 6 times 1, and our that's very wrong. That should be 6 units cubed. So when it's a volume, we do cubed. Okay. Yep. So we have 6 units cubed. And that's because when it's a 3-dimensional shape, we do cube. When we're doing volume, meaning there's 3D, right? There's more than one plane. Excuse me. We say cubed at the end with our units. So it'll be 6 inches cubed, 6 feet cubed, whatever units you're using. Now, this other one, we're going to do the length times the width times the height. Again, so 2 times 4 times 2. And you can do these in any order, so it doesn't really matter. And so we do 2 times 4 first, which is 8, then 8 times 2, which is 16 units cubed. And that is the volume of a rectangular prism. Okay, so now we're going to practice with something right here. Okay, guys, so we're not going to draw in here, okay, so that everybody can focus. Okay, so area, I did not mean to do that. Okay, so the area how do we get area? Somebody can say it out loud.
We get
Times
area. We get
area.
One person at a time. So I think Ridima is talking. Ridima, you can talk.
It's length times width.
Yeah. So can you walk us through this? What are we gonna do here?
So we're gonna do 9 times 6.
Yeah. And do you know what 9 times 6 is?
4
Yeah, you're right. And 54 what?
feet square.
Yeah, you're right. Feet squared. And then perimeter, you can do that too. Perimeter, how do we do perimeter?
You have to add up all the sides.
Yeah, so that would be 2 times the length plus the width. So we're gonna have 2 times, yep, you could go ahead and do that. 2 times 9 plus 6, right? So let's go ahead and there. Oh.
The perimeter is 30.
Oh. That. Okay, so 2 times, why is that not working? That's strange. Okay, 2 times 9 plus 6, yep. So 9 plus 6 is going to be 15, and then times 2. So yeah, you were right. It is 30. Okay, so now let's go to the next one. And we're actually going to skip.
Can I do the next one?
Who is that?
Srivatsa.
Okay, you can do that. We're actually going to do the triangle here, okay? So there is, I'm going to warn you right here, there is something that could mess you up with the area, right? So first, so Srivatsa, which one is the base?
In the triangle?
Yes, so you have these 3 dimensions, right? The 8 inches, 6 inches, and 5 inches. Which one is the base? We're skipping the second.
5. 5.
Oh, yeah, so 5 is a base. Now what's the height?
This is the height.
Which one is the height? Now 5 is the base. Which one is the height?
8.
Is
8
the height?
inches? I should know it's 6, 6.
It's 6.
6
Yeah,
is-
why? Why is it 6?
Because there's this line that measures the height.
Yeah,
Like,
but
then
there,
it's 6 inches.
our real clue is that it makes a right angle right there. That's
Yeah.
why. So what do we do for the area of a triangle? We do 1/2 times base.
Oh
times
yeah,
height.
1/2 times, yeah.
And to make this easier, why don't we put the height first? So 1/2 times 6 is, what's 1/2 times 6?
30.
1/2 times 6, so 6 divided by 2.
Oh, what? That's 3.
Yeah, so 3 times 5 is then?
That's 15.
Yeah, so our area is 15. 15 what?
15 square inches?
Yeah, 15 inches squared. You can say square inches, inches squared. They're the same thing. So now let's do the perimeter, right? So we add up all the sides. Now I'll go ahead and tell you that this side is also 8 inches, right? So how do we do the
Yeah.
perimeter?
So, how we do it is,
So we're gonna add,
it's 21. Is it 21?
yeah, you're right, but let's go through it, okay? So we're gonna
So first I add 8 plus 8, that's 16. Then I add 16 plus 5, that's
yeah,
21.
yeah, you're right. So 15 inches squared and 21 inches. Okay, so now, let's see, how much time do we have left? Okay. So,
Excuse me?
yeah,
I didn't get the triangle, perimeter, and area that well.
the triangle perimeter area. Okay, so what you're gonna do with the triangle perimeter and area is, for the perimeter, you're just gonna add up all the sides just the same, okay? So you're gonna get the length of each side. So this is also 8. Okay? So for perimeter, it's always easy. For any shape, you're just going to add up the edges. Okay? So you're going to add those. So
What
5
about the 6 in the middle?
is 8. That's the inside, right? So that doesn't matter for perimeter. We're going to look at that for area. So 5 plus 8 plus 8, which gives us 21. Now, for the area of a triangle is 1/2 times our base, which is 5, right? And then our height is right here, 6, because this is a right angle. Times 6. So I'm going to do these two first. So 1/2 times 6, so 6 divided by 2 is 3, times 5, which is 15 inches squared. Okay?
Yeah.